Okay, so 8.2 is all about how sets can be represented visually to assist us in the process of understanding what a union or an intersection looks like. So we can have two sets that are being compared or used, or we could have three. Now, most of you have seen a Venn diagram before, but in case you haven't, this is how you would draw it. Now, technically, the Venn diagram with three circles could be one on top and two on the bottom. It doesn't really matter. Okay, so we can label each part of the Venn diagram in order to see what area is what. So if this was a two-set Venn diagram with A and B, we would label one circle A, one circle B. The big box would be U, so there could be some things in the universal set that aren't in A or B. If we look at the center, the two areas that they overlap, this is A intersect B because it's in both circles. If we wanted A union B in one or the other or both, it would be the sum of all of both circles, like all shaded together. In terms of the three circle, we probably have A, B, and C, but we still have U, still A and B. Now this is A intersect B, really with the center too, right? But if this is C down here, the center is actually A intersect B intersect C, all of them together. Here we've got A intersect C. Here we've got B intersect C. It's important that you understand that the middle is also part of each of these, because if it's in A and B and C, then of course it's in A and B, or it's in B and C, or it's in A and C. And we of course have A. This is just A by itself, just B by itself, and just C by itself in those cases. So let's talk about how this can kind of work. Let the left circle be K and the right circle be G. Shade K complement union G. So what does that mean? Complement means or. What does K complement mean? K would mean inside of K. So K complement means outside of K or inside of G or both. So what areas are outside of K or inside of G or both? Well, we know everything inside of G is going to be part of this, right? Because it's at least one of them. But what else is outside of K besides just this area to the right in G? I know if there was the intersection of outside of K and inside of G, this would be the only area. But there's other portions that are outside of K that are not necessarily inside of G, and that's actually the outsides. So the outside is still a viable area because the outside is in neither K nor G, so that they are not in K. So this is something that's kind of tricky logically speaking. Most of us are used to the fact that what or really means in English language, at least the way we use it, is that you usually get one or the other and not both. In math, we don't care if you have both. So we can have inside of G and outside of K, or we can just have one or the other depending on which part of the circle you're in. Now, how do we use this to solve problems? My suggestion will be to always work inside out, and you'll see why, because of the overlapping issues. And before that, it's important to understand a few steps. The number of elements in A union B is the number in A and the number in B minus the number in A intersects B. Now, why is that? Let's say in the classroom you counted all the people who have blonde hair. You counted all the people who had blue eyes. Those are people in set A and set B. What did you do to the people with blonde hair and blue eyes? You counted them twice. So you need to subtract the people that have both characteristics off ones to get their count back down to 1. That's the only reason. So when working on problems with Venn diagrams, you work inside out. But let's talk about this equation. So if the number of elements in A is 10 and the number of elements in B is 6, but there are 2 elements in the intersection, so they have both characteristics, what is the number of elements in A union B? Using this formula, the number in A union B is equal to the number in A plus the number in B minus the number in A intersect B. And you could have any one of these in the equation be the unknown. So as long as you understand how the equation works, you just fill in what goes where. A union B is what we don't know. The number in A is 10. The number in B is 6. The number in A intersect B is 2. So it's 10 plus 6 minus 2, which is 14. So there are 14 elements in A union B. Or the number in A union B equals 14. Now, let's see how we can use information to work inside out. Fill out the entire Venn diagram below given the following information. So they say call the top circle A, second one B, and the last one C, and we'll label U for the outside. It says the number of elements in A union B union C is 10. So that means it's in A and B and C. So where is that? That's right in the center. There's 10 right in the center. Now, it says the number in A union B, or A intersect B, why did I say union? A intersect B intersect C previously was 10. A intersect B is 15. What that means is the areas where A and B overlap is 15. Now, if we look at the two circles A and B, they overlap through the center, which is these two areas. These two areas make up 15. That means if 10 is in the center, that means the other 5 are in A and B, but not in C, so they're not in the center. We can do the same strategy for A intersect C. It says there's 21 between these two areas, which if 10 are in the middle, that leaves 11 out here. It says B intersect C is 13. So again, if 10 are in the middle, that leaves 3 out here for a total of 13. Now it tells us the number total in A is 43. What that means is this whole circle A has 43 elements. We have 11 here, 10 here, and 5 here for a total of 26 that are already spoken for in the circle A. It means the other 43 minus 26, which is 17, go in just A and nothing else. Now it says in A union B, so that's the total of all of these two circles. All 6 of these sections is 69. 17, 28, 38, 43, 46. So it looks like we have 46 already. And so to find out how many are left in B, we take 69 minus 46, and we get 23. So it looks like 23 elements are in B alone. It says the number in C is 26. So that's the circle C. 11 plus 10 plus 3 is 24, which leaves only 2 elements in C. Now it says the number of elements in B complement is 38. That means the total number of elements outside of B is 38. That includes these two sections, A and C, and then A intersect C. But it also includes the outside, which is outside of all the circles. We know all of those add to 38. Now the ones we already know about are 17, 11, and 2. That adds to 30. So if we take 38 minus 30, that actually tells us how much is in the outside, which you can mark it anywhere in the Venn diagram. So in short, understanding what it's asking for and where it is in the Venn diagram makes it very easy to work inside out on this kind of problem. And sometimes they'll give you this kind of thing in a word problem form, but I think you guys can draw it and handle it. And that's really all for 8.2.